Unordered pair, guys, you have to write your answer as x comma y. It's the point that makes both equations true. So we are going to take the point and see, does it make both equations true? When I ask you, tell whether the ordered pair is a solution, I'm asking you to plug it in and check. So plug in the point and check. We need to check to see that it works for both. If it doesn't work for both and only works for one, it's not a solution because it's a system. They have to work together. We are doing one, the first one together. The second one you will try on your own. You are going to take this point, 6, negative 1, and plug it in for x and y. So 6 will go for x, negative 1 for y. First equation. We're going to do 2x. We'll do this one here. So 2x plus 5y equals 7. I'm just copying that down right now. We're going to plug it in and see if it works. What do I put for x now? 6. So 2 times 6. Because 6 was the x value from the point. What do I put for y? Negative 1 in parentheses. And we want to know, is that equal to 7? So you can put like a little question mark if you want. We're checking. We don't know right now. Multiply. 2 times 6 is 12. 5 times negative 1 is negative 5. Is that equal to 7? Well, I know. You probably know by now. 12 plus negative 5 is what, guys? 7. Fantastic. Is it a solution for that equation? Yes, it works. So you can put like a check mark if you want. But here's the thing. It's a system. So it has to work for both, not just the first one. So now you have to take the second equation. I'll do this over here. Negative x plus 2y equals negative 8. And we're going to check that one. So instead of x, we will put 6. Instead of y, we will put negative 1. We want to know, is that equal to negative 8? You can put a little question mark above it if you would like. Negative 6, so it's literally just negative 6. And 2 times negative 1? Negative, so you're doing plus negative 2. Because 2 times negative 1 is negative 2. What's negative 6 plus negative 2? Negative 8. Okay, guys, does negative 8 equal negative 8? Yeah. Okay, it worked for the first equation. It worked for the second equation. So think about this logically. Is it a solution? Yeah, because it works for both. It makes both equations true. You have to tell me, yes, it is a solution. Because it works for both equations. Try it yourself. I'm not going to talk through it necessarily. Did I do something wrong? Oh, I did. It was positive 3. Does it work for the first equation?
Yes.
You bet. So you check the second one as well. It has to work for both.
Does not work for
So you end up getting negative 4 minus 6, which is negative 10. Is negative 10 equal to 7? No. So here's what you would do here. You would draw a slash through the equal sign, which means no, negative 10 is not equal to 7. Is it a solution then? No. Does not work for both. It only works for one. So you would say no, it is not a solution. It would have to work for not one of them, but both of them. If a solution is where the graphs cross, sometimes when you have things that aren't lines, the graphs cross more than once. So you have how many solutions here? Two. There, here, and here. So the solutions, could someone, you can raise your hand. I need the first one. What's the first solution? Addison, what's the first one? Okay. And Aiden, what's the second one? 2, 4. Both points where they cross, you have two solutions for this one. We just did some practice with this on our warm-up. What form are these two equations in? What form? Standard. Ugh, the worst. So you have to put it in slope-intercept form. Both of these equations are in standard form. You can't leave them like this. You have to put them in y equals mx plus b. All right. First one. If you can do this without me, then do it without me. But I'll do it on the board. Let's take this equation, negative x plus y equals negative 7. You have to put it in y equals mx plus b. So solve for y. So it is y equals mx plus b. That's what I'm doing. We have negative x plus y equals negative 7. Jake, how do I move the x term here?
You add x.
Okay. Which would give me y equals negative 7 plus x. It's solved for y. This is in slope-intercept form. This is kind of like one of the ones that we were getting confused on yesterday. So before we graph it, let's write down what we know. The y-intercept as a point, Bobby, is what? Negative 7. So my y-intercept is 0, comma, negative 7. There's not a number in front of x right now. Oh no! What is it?
1.
Thank you. So my slope is 1 over 1. It's puff puff positive, which means that slope dude goes up 1, and he always skis to the right. Okay, we're going to use that in a second. Take the second equation. You have to have both of them in slope-intercept form. X plus 4y equals negative 8. Cole, how do I move the x term? When you do that, you get 4y equals negative 8 minus x. There is not a number in front of x right now, but there is. What is it?
1.
Thank you. To get rid of the 4, Jaden, what do I do? Divide by 4 on both sides, and you get y equals, okay, we got to simplify it. Negative 8 divided by 4, negative 2. And then negative 1 over 4, please leave it as a fraction because that means it's going to be simpler to graph. Negative 1/4 x. Before we graph it, write down what you know. The y-intercept is a number by itself. Hannah, what's my y-intercept here?
2.
Negative 2. So 0, comma, negative 2. That's where you start. The slope is negative 1/4. It's nice negative. Will slope dude go up the mountain or down the mountain? Down 1. And he always skis to the right 4. Okay, you have both equations in slope-intercept form. We've written down what's necessary to graph it. Go ahead and graph these. This one starts at negative 7 on the y-axis and then goes up 1, right 1. So I should see it here, and then it goes up and to the right, 1. And connect those points with a puff positive line. If it seems like I'm taking my sweet time graphing today, it's because I am, because yesterday made me sad, and that's not going to happen again. Not on my watch. Okay. That's your first line. You need to graph the second one as well, which starts at -2 on the y-axis and goes down 1, right 1. -2 on the y-axis is right here. Some of us are trying to graph it on the x-axis. Stop it. It goes on the y-axis. That's where your y-intercept goes. Down 1, right 4. This should be nice and negative. Oh, that was not quite accurate. Ah. If you look at this graph now, you should know where they intersect. Let's write down the solution. The solution's right here. Daniel, what's my solution? 4 and -3. It's a point. First thing I need you to do is make sure, so step 1, make sure one equation is x equals or y equals. Second thing, okay, we just talked about how substitution means replace. So you will replace one equation into the other. Solve the equation just like you did before. So you'll get an answer to one of the variables, the first one. Then you need to plug back in to get the second. Plug back in to get the other variable. Last thing, write it as a point, which will always be x, comma, y. This equation is equal to y. So, if this is like my oil, when I'm making brownies, that's equal to y. So where can I put it in the other equation? For y, substitute it here, because oil is the same as butter. Replace in the equation. Because that's equal to y, I can put it in the spot where y is. So I literally want you to circle that expression right now and draw an arrow. It will help you to do this. So now instead of writing y, I'm going to put 5x minus 1 equals the rest of the equation, equals -10x plus 29. So that part's the same. All I've replaced is what's for y. Just like if you're making brownies, you're not going to change anything else. You're just going to change, instead of putting oil, you'll put butter. Okay, we know how to solve equations. We spent like 2 months on solving equations. So, solve. You have variables on both sides. Do we like that? No. You gotta move your variables to one side. You can move either one. It does not matter. Personally, I'm gonna move the -10x because that will keep things positive. Right now it's -10x. So how do you move it, guys? Add. Oh, not 5. 10. Add the 10x to both sides, which will cancel that out. So now on the left, you have 15x minus 1 equals 29. You're solving for x. You're getting x by itself. I see -1. How do I undo it? Add 1. doing the inverse operations. Flashback to unit 1. 15x equals 30. X is almost by itself. I see multiplication, so I undo it with the inverse of division. And so x is equal to? Okay. That's important, but it's not your final answer, so maybe circle it or something. So that was step 3, solve the equation. Check. Done. Step 4, plug back in to get the other variable being y in your case, because you have x. It does not matter which equation that you choose to use, whichever one looks easier to you. Personally, I think this bottom one will probably go a little bit better because the 5 is positive and the numbers are smaller, so I'm going to use that one. It doesn't matter which one you choose. So y equals 5x minus 1 is the one I'm using. This is kind of like what you did on your warm-up when you're checking solutions. So now, instead of x, what are we going to put? 2. So y equals 5, but not x, 2, minus 1. And 5 times 2 is 10. And 10 minus 1 is 9. You have x, you have y. Write your answer as a point. 2, 9. Because you could graph these two things, and remember we've talked about the last 2 days, the solution is where they intersect. So if you graph these two lines, 2, 9 is where the lines will cross. That's your final answer. Make sure you write it as a point.